Hello everyone, welcome to the last section on similarity. And I know we're not super huge fans of word problems usually, but that's what this section is on. Now the good news is, for every single word problem we're going to be setting up proportions. Everything is going to be working like scales, just like we have been doing with polygons and everything so far. So, remember, keep your units together. Okay, you always want to make sure that whatever your units are, whether it's centimeters, meters, inches, feet, and you'll see today dollars or euros or miles or whatever, make sure your units are together. And we're going to round all our answers to the nearest tenth, so that's 1 decimal place. Okay, so always to 1 decimal place, and since they're word problems, you are going to have units on all of your answers here. So let's look at our first problem. The scale on a map is 1.25 inches to 16 miles. If two cities are 121 miles apart, how far apart will the two cities be on the map? So this first scale that they give us, 1.25 inches to 16 miles, that's going to be my first fraction. 1.25 inches to 16 miles. Now my second fraction, remember I said I want to keep my units together, so I'm going to put inches on the top and miles on the bottom. So it tells me 121 miles apart, so that's going to go on the bottom. And then how far apart will the two cities be on the map? That's going to be x. That's what I'm trying to find out. And now I have my proportion set up, and now we can just cross multiply like we have been the whole time. So when I cross multiply, I get that 16 times x is 151.25. That's 1.25 times 121. Then I'll divide both sides by 16. And x is going to be 9.5. And remember our units. We're finding x, so that's in the numerator, so that's inches. And there's my final answer. So for every single problem moving forward, we're going to do the exact same thing. Set up a proportion and solve. So, the shadow of a house is 6 feet. If the 10-foot basketball hoop in the driveway casts a 1.5-foot shadow, how tall is the house? Now this one's a little tricky because everything is in feet. The shadow is in feet and the actual object is in feet. So the units are all going to be feet. So it's going to be a little bit trickier to tell where to put things. But if I put the shadow in my numerator, so my shadow of the house is 6 feet, and then the basketball hoop has a 1.5-foot shadow, I've put both of my shadows, I can see, on the top line. So this is for the house, and this is for the basketball hoop. Now, the actual height, we don't know what the actual height of the house is. That's what we're trying to find. But the actual basketball hoop is 10 feet tall. We would set it up like that. So you can see I have my actual heights on the bottom, my shadow heights on the top, and then this fraction is for the house, and this fraction is for the basketball. Okay, or the basketball hoop. Now, I can cross multiply from here. So I get 1.5x equals 60, 6 times 10. Divide both sides by 1.5. And x is 40. And remember, everything was in feet, so this is in feet as well. So the house is 40 feet high. Okay? And when you're done with these problems, you should always look and see, does it make sense? Does it make sense for a house to be 40 feet high? Sure. If your answer is 2, then you would probably say, well, you can't have a house that's 2 feet high. All right, that won't work. Okay, the next one. The exchange rate. Okay, so dollars to euros is 2 euros equals $2.40. So there's my first fraction right there. 2 to $2.40. And I can't remember what the symbol for euros is. I think it looks like that. So 2 euros to $2.40. And now I'm taking $250 with me, and how many euros would I get? So X is my euros, and dollars goes on the bottom there. So cross multiply. So I get 2.40x is 500. Divide by 2.4, or 2.40. And x is going to be, now I have to round this, 208.3 euros. And if you don't know the symbol for euros, that's fine. You can just write it out. Now, this one is one that you'll see you're very familiar with, miles per hour. Okay, if you've been traveling for 3 hours and 15 minutes, how many miles have you gone? Well, when you see miles per hour, mph, what that means is it'll take you 1 hour to drive 56 miles. So I can write that as a fraction. 56 miles per 1 hour of driving. Now, I've been traveling for 3 hours and 15 minutes. So I have to think, how am I going to make that into a number that I can use here? So I have to turn 3 hours and 15 minutes into a decimal. So 15 minutes is a quarter of an hour. So that's going to be 3.25 hours. Or you can think of it as 15 over 60. Because there's 60 minutes in an hour, so 15 over 60, that's still 1/4, which is 0.25. So it's 3.25 hours, and I'm going to know how many miles I've gone. So that's my x. So now I'm going to cross multiply. So I get 1x is 182 miles. And I don't need to divide by 1. I mean, you can, but you're still just going to get 182. So in a shipment of 400 wrenches, 14 are defective. How many would you expect to be defective in a shipment of 1,800? So I have 14 defective in a shipment of 400 wrenches. So how many would be defective in a shipment of 1,800 wrenches? So I set it up like this. Now I can cross multiply. So 400x equals 25,200. Divide by 400. And I would expect there to be 63 defective wrenches. So a car travels 135 miles in 3 hours. If it's traveling at the same rate, how far would it travel in 5 hours? So how many miles is it going to go? So again, cross multiply. So I have 3x is 675. Divide by 3. So x is 225 miles. And finally, Molly bought 2 heads of lettuce for $2.80. How many heads of lettuce could AJ buy with $33.60? So 2 heads of lettuce for $2.80. How many could we buy for $33.60? So I'm going to cross multiply. So I get 2.8x equals 67.2. And when I divide, I get that x is 24 heads of lettuce. Okay, so for all of these, you're just setting up proportions. Remember to keep your units together. Okay? And don't forget to write your units at the end. If you have any questions, feel free to watch this again, or you can ask me.